We're taking a look at some geometric sequences here, and we're looking at missing terms. In this first term, we start with -9, and then we have a missing term. I'm going to actually just put underneath my -9, if I was in function notation, -9 would be f of 1. The blank would be f of 2, and then f of 3 would be -81. If I was using sequence notation, I would say the first term, which is just a with a little 1 by it, is -9. A with a little 2 by it is the second one, and a with a little 3 by it is the third one. They're just ways of kind of writing notes to yourself. I like the A notation better. It's a little bit easier to use. So over here, if I wanted to plug my numbers in, I could say -81 is -9 times my ratio. I don't know what my ratio is, but since this has been multiplied by my ratio twice, to get from -9 to -81, I could put a 2 there. Now, if that doesn't make any sense to you, let's look at it this way. All right, every time I see a comma, I'm multiplying by my ratio. So here, I would times by my ratio to get from -9 to that blank. And to get from that blank to -81, I'm timesing by my ratio again. So I could say -9 times r equals -81. Let's simplify that a little bit. I'm going to give myself some room over here. I'm going to put my r's together. I'm going to say -9 times r squared equals -81. Sorry about my dog in the background. I'm going to divide by -9. I get my r squared equals 9. Well, just like on the Pythagorean theorem, if you've got r squared and you want to get rid of the squared, you do the opposite of squaring. You take the square root and it cancels out the square. So my ratio, in this case, is 3. Let's go back and see if it works. So -9 times 3, that would make 27, and it would still be negative. 27 times 3 would make -81. That worked. All right, let's do that with this next one. Let's make a little equation where every time we see a comma, we're multiplying by our ratio. So it's going to be 5 times my ratio times my ratio times my ratio equals 40. We can consolidate that into a little bit better equation. 5 times my ratio cubed equals 40. Let's just try to get our ratio cubed by itself. Again, I apologize for my squeaky dog. And we're going to get my ratio cubed equals 8. Well, this is starting to look kind of weird, but we're looking for something cubed that equals 8. Let's write this out again like we had it before. Ratio times ratio times ratio equals 8. What could that be? We haven't talked a lot about cubed roots, and this is a much harder example than we'll probably see very often, but a ratio is actually 2 on this one. That's a 2. All right, so now let's take our ratio and we'll go back and we'll find out using our ratio what the missing numbers are. So that means every time we see a comma, we're multiplying by 2. So timesing by 2, timesing by 2. That gives us 10 and 20. And that seems like it works because if we did it another time, we'd get 40.